Hello, good morning students. So we'll talk about a new topic in this video. But first, let us revise what we did in the previous video. I gave you a few examples of finding the total resistance and current flow in the circuit, and then we simplified the circuits and moved forward. Now in this video, we are talking about another important point of this electricity, that is electric power. Because when we talk about energy, we are talking about power. In the previous standard, we studied about kinetic energy, potential energy, work done, and then we studied about power, if you remember. So what was the definition of power? In 9th standard, we studied that power is nothing but work done in a certain amount of time, and that is true. But this power is being utilized by electrical energy. It is not some machine, or even if it is a machine, it is using electrical energy. So we'll have to talk about electric power now. So what we simply need to do is convert this formula of power into electrical values. Now work done. Over here in the very beginning we studied about some sort of work done. If you remember, I'll rephrase it for you. We talked about electric current, we talked about potential difference. So what was potential difference? Potential difference V is equal to work done upon charges, that is work done in moving unit charge from one end to the other end of the conductor. Work done in moving. So we had potential difference V is equal to work done in moving unit charge from one end to the other end of the conductor. So we'll use that formula. Potential difference V is equal to work done in moving unit charge from one end to the other end of the conductor. We require work done, so we'll move this. V into Q is equal to work done. Therefore work done is equal to V into Q, that is potential difference into charges. Now what do? We use this value of work done in our formula, that is power is equal to work done upon time taken. So what we get is, therefore P is equal to V into Q upon T. Understood? What we did was P is equal to V into Q upon T. So this is what we have done already. Now we have converted somewhat the formula of power, that is work done upon time taken, into somewhat electrical power. But still we are not done. If you remember, what was electric current? So in the very beginning we studied electric current I is equal to Q upon T, that is number of charges flowing in a circuit in a certain amount of time. So the number of charges flowing in a circuit in a certain amount of time. So that current I is equal to Q upon T, and we already have over here Q upon T. So we are doing power P is equal to V into Q upon T. Because they all are in multiplication, I can separate this T in the form of Q upon T, and Q upon T is electric current. So I replace this Q upon T with electric current I. So the power P is equal to V into I. So the electric power P is equal to VI. I hope it is clear to all the students. I'll repeat for you once again what is electric power. So electric power is work done upon time taken, but we have to convert this power into the terms of electric current, and that is why we recall the formula for potential difference, that is V is equal to work done in moving unit charge from one point to the other point of the conductor. Simple cross multiplication, Q cross multiplied potential difference into Q, so V into Q becomes W. So we can write work done is equal to potential difference into charges, and we use this formula of work done in our powers formula. So P is equal to W upon T. Now W is VQ, so we write V into Q upon T. And we also studied about electric current I is equal to Q upon T. And now we have this power formula P is equal to V into Q upon T, because this is in multiplication and T is in multiplication or in division with both V and Q. So I can separate T only with Q. So V into Q upon T. And we know that Q upon T is current. So instead of writing Q upon T, I am writing current. So the formula for electric power P is equal to VI. I hope it is clear to you. Yes? Okay. So the unit of electric power is once again the same as the unit of power that we studied last year. So the unit of power was watt. If you remember, we had the question, what is 1 watt? And 1 watt can be defined as 1 joule of work done upon 1 joule of work done upon 1 second. That is, 1 joule of work done in 1 second was known as power. Over here we have P is equal to VI. So what is 1 watt? So we can write 1 watt as 1 watt is equal to 1 volt into 1 ampere, which means that 1 watt of electric power is consumed when potential difference is 1 volt and current flowing is 1 ampere. I repeat, 1 watt of electric power is consumed when potential difference is 1 volt and current flowing is 1 ampere. I hope it is clear to all the students. Yes? Okay. Now students, this formula of electric power, that is P is equal to VI, can be modified according to our needs of solving the equations or solving the problems using the circuit. We know that Ohm's law, V is equal to IR. So in the circuit, suppose we are given only current and resistance and no potential difference is given. For your problems, suppose you have been given a practical problem and it is defined in the question that you are only given current and resistance but no potential difference is given. So you can use this formula and substitute this value of V in V over here, that is in equation of power. So over here this is our Ohm's law and this is the formula for electric power. We name it number 1. So we use this formula of Ohm's law in this, and what we get over here is P is equal to, instead of V we write I into R into I, this I as it is, and instead of potential difference we are writing IR. Now because they are all in multiplication, I can write I into I as I square, so I get power P is equal to I square R. This is another formula for electric power. I hope it is clear. We used Ohm's law to substitute the value of V, that is potential difference, in the powers formula, and we got another formula for solving electric power. In the same way, suppose the current is not given but the potential difference and the resistance of the device used, that we know, but we don't know the current. So once again we can use Ohm's law and use the value of current I. Okay, we have Ohm's law, V is equal to IR. Taking cross multiplication over here, we get V upon R is equal to I. Therefore I is equal to V by R. Once again, this is our Ohm's law, and we use this value of I in the powers formula, that is P is equal to VI, and we know that P is equal to V. And what is I? I is V by R. So again we are writing V by R. Once again they are in multiplication. So we multiply V by V. What we get is V square by R. So another formula for electric power is P is equal to V square by R. This is the formula that we are going to use in many of the practical problems that we solve. So we have power P is equal to VI. We applied Ohm's law. We got value of V as IR. Substituting that value in power, we get P is equal to IR into I. So P becomes I square R. Another formula for power of the electric circuit. In the same way, we have V is equal to IR. We need to find the value of current I. So R is taken in cross multiplication on the other side of equation. So V by R becomes I. Therefore I is equal to V by R, Ohm's law, and P is equal to V square by R is equal to V square. V into V by R becomes V square by R. Therefore power P is equal to V square by R. I hope it is understood to all of the students. Okay students, so now I have a question for you, that is, an electric fan runs at 220 volts supply and the current flowing in it is 0.5 amperes. Find its electric power and energy consumed in 2 minutes. So first of all we need to find electric power, which is quite simple. Electric power P is equal to VI, that is power of the fan, and potential difference is given 220 volts, current is given as 0.5. When you simply multiply it, you will get 110, that is watt. So the power of the fan is 110 watts. Now the other part of the question is how much energy is consumed in 2 minutes. So for this we will use the formula of the power that we studied in 9th standard. Power is equal to work done upon time taken, if you remember. And we have also studied that work done is equal to energy consumed. So whatever the work is done, that much amount of energy has been consumed. So we can write over here power is equal to energy consumed upon time taken, or the rate at which the energy is consumed is called power. If you remember one of the definitions of power last year. So we have energy, how much of the energy is consumed in 2 minutes. So we have the power, that is 110 watts. So we will write that over here. Energy upon time taken is 2 minutes. Because we know that minutes is not used, always convert minutes in seconds. So we have 2 into 60. Cross multiplying it, what we get is 110 into 2 into 60 is 120 seconds, that is equal to energy consumed. And when you multiply 110 into 120, you get what is 13200 joules. So the answer that you get is 13200 joules by simple multiplication. Or you can write it dividing it by 1000 from last year, if you remember, that is 13.2 kilojoules. So this much amount of energy, 13.2 kilojoules, this much amount of energy has been consumed by the fan in 2 minutes. Okay, so we'll revise the whole question once again. An electric fan runs at 220 volts and current is 0.5 amperes. Find its electric power and energy in 2 minutes. So the potential difference into current gives us power. So P is equal to VI, 220 into 0.5. We get the answer is 110 watts. Now we use the formula of power that was previously that we knew, that is power is equal to work done upon time taken. Work done is equal to energy consumed. So we can write P is equal to E upon T. Okay, and time is 2 minutes into 60 seconds. So we get 120 seconds. Cross multiplying it, because power is 110 into 120 is equal to E. Simple multiplication gives you 13,200 joules, and converting it into kilojoules, we can divide it by 1000. You get the answer as 13.2 kilojoules. Okay students, that's it for today. I hope you have understood all the concept that I have taught you today regarding electric power. We converted normal formula of electric power into formula of power into electric power by using potential difference and the formula of current, and what you get is P is equal to VI. Finally, P is equal to VI. Its unit is watt, just like before, and converting this formula of power P is equal to VI in the forms of just current and just in the forms of potential difference. So if it is in the form of current, is it P is equal to IR square. In the form of current, is P is equal to V square by R. We'll talk more about this electric power in the next video. Have a good day.